Hello and welcome. So we're happy to be able to talk about getting some smartness into Dynamics NAV today. My name is Klaus, Marius, Hansen, and this is Jesper, Schulz, So we're both with the NAV application team. I'm a software architect in that team, among others, responsible for what we are talking about today. And Jesper?
Yeah, and I've been working at the mothership, MS, for like 8.5 years now. The last half year I've been spending on trying to make NAV smarter through notifications. And today I'll be your guide through the world of notifications in a couple of minutes from now, yeah.
Right, so we have two major things that we would like to share with you. So first of all, we'll do a brief introduction of what we think is a new interaction approach in NAV and in ERP systems in general. Talk a bit about that. Then Jesper will talk about or give you all the details of notifications, and in particular the notification API that we have introduced in NAV 2017. And following that, I'll introduce you to Cortana Intelligence. We'll do a deep dive into machine learning, and I'll show you how you can leverage that inside NAV, and we'll also peek into how you can, in general, use Cortana Intelligence from NAV in other ways than by the APIs that we have integrated. So first, as smarter NAV, so what do we actually mean with that? Jesper and I will give you a bunch of examples today, but I think basically we're trying to add things to NAV, not necessarily machine learning or Cortana Intelligence, that makes NAV appear smarter. So traditionally, NAV and ERP systems in general, they react to user input only. So I need a cash flow forecast, I need to update various worksheets, I need to press a button, I need to go into another worksheet, I need to read out a chart and so on. But what if Dynamics NAV could instead be proactive, so instead of just reacting to what users do, also notify users, give users the right information in the right context. So a couple of examples, and we'll give many more. So for example, it might be that if a user signs up to, let's say, Dynamics 365, get into an empty company, then a natural thing to ask would be, well, hey, wouldn't you like to migrate your data from your previous system? So if you have customers in QuickBooks, Sage, or whatever, let us migrate them. And another example might be that, well, while you are selling your items, many of those, or the customer is selling many of those, let's keep track of the inventory and notify the customer when something is running out of stock. So these are two examples that we have built into NAV 2017. And so we're still at an early stage, I would say, and we are going to look a bit forward also in this session. But the two things we have and we would like to show is then this notification framework, which is basically an API to notify users in the context of their work, such as when doing purchase orders or sales invoice and so on, and a deep integration of Cortana Intelligence. Jesper.
All right, so notifications. They've been mentioned in a few sessions before this one, but they've only been briefly touched upon. I'll try to go a little bit deeper into what notifications are and when we should use those. Since you're at this conference, I assume you're all familiar with NAV. So that also means that you're familiar with a dialogue like this. Hold on, I know you're busy to fill out this invoice. I just want to annoy you with a question right here, right now. Do you mind? Obviously we do, because you're in a zone, you're in the flow, you just want to fill out a bunch of lines, and now these annoying message boxes and dialogues pop up and interrupt you. And you're probably also familiar with this. Whenever you would like NAV to offer a little bit of assistance, well, there is nothing to get. You just get stuck, and NAV is painfully silent. So the primary motivation behind our notifications are to go from interrupting and telling to suggesting and gently nudging in the right direction. And also to go from silence to lending a helping hand. So this is where we should leverage the power of notifications. So I'm going to start this, this little talk with a demo, and I'm going to end it with a demo, just to like keep your attention. And then in the middle, I'm going to walk through a million of slides to bore you to death. No, I won't. This will be very much hand-on. I'm going to spend most of the time in NAV and coding, and we'll have just a few slides with the very basics. So let's dive into it. Switch the computer. So this should look familiar. And as Klaus just mentioned, this is a completely new installation. You see there are no quotes, nothing in here. So let's assume that I go to my vendors. So these are actually notifications that we already implemented into the system. So if I click on my vendors, now you'll see want to import entries, which is, of course, a very nice suggestion for someone who has never worked with it. Because if you like go up in here and you're completely lost, I want to import, import from data file. It might be a little bit complex to figure out how you should get your data into NAV, whereas this is just a click away, and off you go. And also, for the trained user who does not want that, and maybe use Rapid Start or whatever to get his data in, he can simply ignore this notification. So it's not really requiring any attention unless you want to. So the other example would be, let's say we have a customer, Yahoo Plumbing, where we can create a sales invoice. So what would a plumber need? So he might need, of course, a plumber's helper. So before, if you ran out of inventory, you would get stopped in your flow. Now this allows you to respond to this message at a later point in time. You can just first start entering all information that you need. Let's say he also needs one of those. Drain cleaner, obviously. Maybe even 10. See, now the notifications start stacking up. But you can still keep on working. And then in the end, when you you can take a look. Okay, what is this? I don't care about his credit limit. I know him. He's a good guy. So I might just discard this one. Or, yeah, man, I forgot to order some new plumber's helper. I will go into details with that right now. I'll start creating a purchase invoice. So you can do all from one spot without being interrupted in your normal workflow. So this is the intention behind those notifications. I'm going to exit that one. Okay. So the takeaway is the notification is subtle and unobtrusive. It never gets in your way while you're in your zone. It merely suggests a course of action. This is the absolute key for those. So when should those be used? Well, do use them when you want to suggest a course of action related to the context the user is in. So whenever, well, what you just saw, whenever you're in the right context and you want to suggest an action, this is where we can use them. Also, you could provide some additional contextual information. Let's say you chose a customer which is a premium customer or something, then you want a notification. Well, this customer is one of your best customers. Be extra careful when filling out some information or something. Or, of course, if you want to assist the user in using the product. Like if you're building extensions and they require some setup, it would be a nice thing, for instance, to show a notification wherever that extension makes sense and say, hey, you haven't set this up yet, would you like to do it now, enable this and that functionality, so that the user doesn't have to go in and search for setups or doesn't have to go in and search for ideas. NAV will present them. One could also imagine something like, did you know that you can also, like the 6th time that the user opens a page, or if you very often enter the same information, you can have some machine learning behind it that sees, okay, you are always entering this and that information, it's the same, and then it could suggest, hey, should we not default to this? So there are like various examples of what you could do with these. However, there are also situations where you should not use them. Whenever you want to make sure that the user takes action, or you want to make sure that he's aware of a certain condition, then a notification is not the right way to go, because you want the user to do an active gesture and saying, yes, I understood this. So for instance, you should never ever try to take an error and turn it into a notification. That would just be, well, nonsense. And also, you should not use this kind of notification if you want to provide information which is unrelated to the current context. So we are planning on this global notification concept, but we're not quite there yet. So these notifications are what we call in-context notifications. They should only be used, for stuff that's context relevant. So don't try to implement something where you start sending messages to users across the And like, did all of a sudden these bars come up because that will just, well, be abusing the notifications and the user will start disregarding them, and that is not the idea here. So where do they work? Well, they work everywhere. You've seen them working on the web client, obviously. They work on the phone, they work on the tablet. They also work in the Outlook add-in, and also they work on our Windows client. Moving on. Moving on. Here we go. How do they work? Now, we spend a fair amount of time to make this API as easy to use as possible. So actually, you will not know where this notification comes from. It can be called from the header of section of a page or a table. It can be called from the lines, from fact boxes, from a code unit that calls a code unit that calls a code unit. Wherever you call it from, it will always be displayed in the right place. And if not, please file a bug. So, time to get serious. The API. Well, as you can see, it is not that big yet. We've got 2.5 properties. 2.5. Well, we've got the message, which specifies the actual message that you want to display to the user. Then we've got the ID. Now you can assign an ID if you want to be able to reconnect to the notification in case you want to update it or you want to recall it. Else that's an optional property. Then you have the scope. Well, at the moment it's local only, so there's no need to pay any attention to this one. Eventually, at some point, I hope there will be a global. Then we've got the functions, first one being send, which is probably the most important one. As soon as you invoke send, the message will appear to the user. We've got recall, well, it kind of says it all. Recalls the notification if the ID property is set. Then we've got the add action, adds an action. And then the paired set data and get data. Where you can assign data to the notification and retrieve it again. I'll of course go into detail with those when we start coding, which would be now. So, time to get our hands dirty. Let's get out of the client and into this one. So we're going to start out with a completely empty code unit, except for the documentation. So ideally, when you implement notifications, you should use our event model. You do not want to add the notifications directly on the page, even though they are UI related, but some of them might be reusable. So they should live in a code unit of themselves. And obviously, you should not put them on tables. So the best idea is, of course, to use an event subscriber. So let's do that. So I've added an event subscriber here on after customer postcode validates. So whenever the postcode is validated, then this trigger is run. In we get the customer, the previous customer, and the field number from which this was invoked. And from in here, we just call a local function, create address lookup notification, where we will set the message. This is our first notification. It's rather useless. And we'll fire it. So let's see if that works. Let's create a new customer. And we enter some kind of a new postcode. And there we go. This is our first notification, rather useless. Indeed it is. So far so good. Now, let's try to add an action to make this a little bit more useful. So I'm just going to create one more function. So the event subscriber stays the same. The message has now slightly changed, but now what we do is that we add some data, because now when there's an action, we typically want to react or do something to an object, right? So for that, we need to store whatever object or whatever information we want in the notification so that we can retrieve it again whenever the action is fired. So set data takes a name. You can choose whatever you want to, and it takes a value. Now this could also, in this case, since the customer has a primary key of just one field, I'd simply take the customer number. You could also choose to take a record ID if it has a more complex key. You can, of course, also use set data various times if you want to add more information to the notification. So now we've stored the customer number into the notification, and now we can add an action. Click here to get amazed. You then specify the code unit ID, where you will find the function that is to be invoked, and you give the function name. The function that you call needs to be public, and it needs to have a notification as a parameter. That's the only prerequisite. And then, of course, it needs to reside in the code unit as specified here. And then that method will be invoked. So what we're doing here is that this notification, of course, contains the notification where the event was invoked from. So we retrieve the customer number with the getData function, and we get our customer. We change the address to you did not see that coming, street 1, and we modify the customer. So let's see how that works. For the fun of it, let's do it in the phone. So we go into our customers, and I create a new one, like that. And I enter some kind of postcode, 1, 2, 3, 4. And here we go. So click here to get amazed. Let's see. No, we did not see that coming now, did we? So that's how easy it actually is to get data in, get data out, modify records. That button. So, but this is still very much constructed. So let's try to make this this very, very useful, and try to hook it up to. You might have seen this already in the presentation of our lovely new IDE. But I've tried to extend it so that we actually now can contact a service with some, for instance, the zip code or a phone number. The service will then try to retrieve company or the customer information, and if it can do that and it can identify that exactly one customer is found, then it will auto-complete the address. So let's try to hook this notification up to that service. Like that. So first of all, I've now also added another event subscriber which calls into the exact same function. Ideally, of course, I mean, you add it to every single field that you want to launch the notification from. So now we have 2 of them. So now if the create notification is changed slightly because we go into this lookup address service, which I will not show you here because it's a little bit more complex. And it simply checks for this customer, does this customer have enough information, so that we can find the address of him. And if we can, well, then we show the notification. If not, then not. So this actually also comes in handy because this communication and figuring out running this algorithm might actually take a while, right? So if you would use like a button to say, hey, can you now auto-complete my address? And then the user would have to wait, no, and then comes a response, no, I can't. That would be an annoying experience, right? But this notification can just come up whenever the service is ready and has returned something. So it kind of is slightly async, even though we're still in the context. So this one hasn't changed at all. And the complete address now obviously updates the customer with the address information instead of just setting some address field. So let's see how that works. I can now take the, for instance, phone number. Just need to make sure it's updated. So if I now paste in the phone number, well, that actually went pretty fast. So it finds it, and we can now click Update Address, and we'll find our Microsoft Development Center. Yeah, well, and fill it in. So that was fairly simple. But now what happens if I, for instance, take my phone number? So now we get the first notification, and then I take, I don't know. So in England, there are some zip codes which actually relate to one specific address, not even a set of them. For instance, GlaxoSmithKline is big enough to have their own zip code. So if I use those, then you can uniquely identify the address. Well, now it found 2. That, of course, is not ideal. At any given time, we only want one of these notifications, right? So this is where the recall comes in. So let me update the code and add some recall functionality. All right, so primarily what we need to do is to assign an ID to the notification. The notification ID, in this case, I just made a little function where I pasted in a GUID, because at any given time I only ever want one of these notifications. There cannot be multiple lines and multiple variations of this notification. There's only one. So you might as well just assign one ID, so that at any given time I can get in contact with that notification again. And now what that does, if I save it, let me get rid of those. I'll create a new one. And add this, and we get one notification. And now, if all goes well, we still only get one notification. So this notification is now updated with the latest information. So that's already good. But let's say that we actually take a valid postcode here. And we say update address. Oh, sorry, that's not what I wanted. Let's try that again. I get the notification, but it's actually not what I want. I want to enter the address myself. Then it wouldn't make sense to keep displaying this notification, right? So if I now start entering an address, then the notification should go away. So how do we do that? That is fairly simple. Now I've added another event subscriber to the onAfter address validate. And if the user enters an address, chances are, well, he doesn't want the auto-completion functionality, hence we use the recall notification function. And what that does is simply it has a local variable, which is our notification. We assign the ID to this function again, and we call the recall, and the notification disappears. So this is kind of the essential bits and pieces of notifications that you've got here. Yeah, let's get back to the presentation. So there's one final thing that I want to show you. So we're working a lot on these notifications, so you can expect a lot of goodies coming up in the following releases. But we managed to squeeze one thing into NAV before we released, very much last minute. So there might be certain notifications that simply annoy you and you just don't want to see them. Let's say your boss installed some extension and it keeps on like flooding you with these notifications and you're just not interested. So you need some way of turning them off, right? As you can on every device these days. So obviously we needed something similar. So we've created something that we call My Notifications, which is our notification center. You can subscribe to this lovely publisher called Uninitializing Notification with Default State. And then you can call two functions, which will allow the user to enable or disable it. So let me show you how that works. This will be the last bits of code here. All right. So I have subscribed to Uninitializing Notification with Default State. And by subscribing to it, we register our notification in the My Notifications page. So all we need to do is call My Notifications, which is a record. And then we say insert default. We add the notification ID, which is now required in order to identify the notification, obviously. It needs a name, it needs a description, and then it needs the default state. If it should be enabled by default or disabled by default. So by doing that, when you go into My Settings, change when I receive notifications, you will see our little address lookup service here, which you can now tick on, tick off. There's also a different function in there that you can use where you can then pass in the record as well, and then you can specify filters. Like for instance, I want to see this notification for a certain range of IDs, or if a certain Boolean is set or whatever, and else I do not want to see it. So it's actually pretty neatly controllable. So now, of course, if I disable it, just for the sake of completeness, let me take that one again. Ah, damn it. this. Well, yeah, nothing happens. Great. So the only thing that we now need to implement is in this where we create the notification, this part. If not my notifications is enabled with this ID, well then exit. And that's basically it. So that should be fairly straightforward to code up against. We are currently working on something that we call notification lifecycle management, where you can store all the active notifications for a given user, and you can dispose them, and you can like if you have multiple sales lines, you can get multiple notifications, and if you then, for instance, change a sales line, then that particular notification will go away again. And in order for that to work, of course, all the notifications need different IDs. So it can get a bit hairy, so we're creating a little framework for that. We will soon be posting a pattern on that, so stay tuned. And that basically completes my part, and I'll of course be happy to answer any questions that you might have about notifications in our Q&A section.
Okay, thanks Jesper. So let's turn to some of the underlying data sources for these notifications. So and let's turn to Cortana Intelligence. So what I'm going to do is to talk about what Cortana Intelligence is, and I'm going to focus specifically on machine learning, because that's what we have focused on in NAV 2017. I will give some examples of how Cortana Intelligence is used in NAV, show how you could use Cortana Intelligence directly using built-in APIs, and also how you can use Cortana Intelligence integration. So, so what is Cortana Intelligence? So it's, well, I guess it's a marketing name, but it's also built on the premise that we get more and more data from diverse sources. So to the left up here, we have a bunch of data sources that generate lots of data. Data is worthless unless we can act upon it in some meaningful way. And what Cortana Intelligence promises is to have tools that will allow you to transform data into actionable information. So in what we've been looking at in NAV 2017, the primary source of data is apps and NAV in particular. But it could be anything else, a lot of other things. So it could be sensors that you have in a warehouse. It could be data about how users use an application. It could be external data sources such as weather forecasts and so on. Lots and lots of data. So what Cortana Intelligence then provides is a technology stack that goes all the way from very basic information and data management to what we call pre-configured solutions. So data information management is all about retrieving data, transforming data, copying data, and so on. There's the ability to store data in big data stores, not SQL Server, but for example, Azure Data Lake. And then the fun stuff starts up here. So machine learning and analytics are part of this. What is called Azure Machine Learning and Power BI is up here, dashboards. And finally, there are pre-configured solutions, one of which we've built into NAV 2017. Right, so this is just a rendering, same information, but a bit more detail. And what I'm going to talk about now is machine learning. So what is machine learning and how can we use it in NAV? So first of all, I'm going to spend 10 minutes or so just talking about machine learning, giving some examples that are relevant to NAV. So this is not necessarily a prerequisite for using the APIs that we have built into NAV, but I think it gives, well, it's useful to have an understanding of what is going on underneath these. So I have some scenarios here, and I have some different types of machine learning. But first of all, machine learning is a way to teach a system to make predictions for future data based on historical data. It's a bit different formulation than the one Vincent came up with, but I think it makes good sense. So let's take a couple of examples. So one example is the first one here. Will we have stock out of an item? So as we are selling bicycles, when will we run out of stock at some point? In that case, the historical data would be historical sales of that item, right? So last month we sold 20, the month before we sold 15, we sold 10, 5, and so on. Very easy regression here. So we probably sell 30 the next month, and if our inventory is below 30, well, we'll probably run out of stock, right? So the prediction we want to make in that case is the inventory level for an item, or many items. Another example of a scenario would be, will we run out of cash? So will a company run out of cash? In that case, what we want to predict is actually cash flow. So how much cash is coming in, how much cash is going out, what is the balance between those two? And the historical data that we then need in order to do that kind of prediction is payables and receivables history, at least. There may be other things that we would want. But if we have that history, we can make a prediction based on that. A third example is whether a customer will pay an invoice late, which might also be useful in this cash flow situation. So in that case, when we are creating a sales invoice, shipping something to a customer, we would want to predict, yes, no, will the customer pay late? So how do we enable that? How do we teach a system to do that? Those kind of predictions, we need some historical data, and in that case, the historical data would be historical sales invoices for customers with payment dates, so you can determine whether you paid late or not. Fourth example would be which items can I sell to this customer, right? So if I'm in a conversation with a customer, what are the most likely items that the customers buy? That would be the prediction that I could want to make. And how do I enable that prediction? Well, I could do that by having a transaction history for item bought by customers, and then try to find similar customers that are similar to the one that I'm doing the prediction for. My last example is the scenario is which discount rate is optimal for this sales invoice. So the idea would be to find a discount rate that would be optimal such that the customer will actually buy based on the quote, and we would get the optimal amount of profit. And the historical data there would then be at least sales quotes and invoice histories. So I chose to have these 5 examples because they both span types of machine learning that is interesting in ERP or financial applications, and they also show what we have built in and what is enabled using Azure ML. So the first 2 examples up there, they are examples of forecasting or time series forecasting. So the historical data for an item is a time series, and what you can try to do is to continue that time series based on properties of the historical data. So that's built directly into NAV 2017 using the time series API. The third one, this one about will the customer pay late, yes or no? That's a classification. It's actually a binary classification. So we're taking some data and putting it into one of 2 classes, yes or no, 0 or 1, true or false. The fourth one is recommendation. So you basically try to find items, in this case, to recommend to customers based on either items they've bought previously, so items that are close to those items, or customers that are close in some way to the customer. And the last one is then regression, so finding a numerical value based on historical data. The last 3, right now, we'll have to use Azure ML integration. I'll show an example of that. We hope to build APIs for these in the future, but no guarantees on that. So let's take one of those this late payment prediction example. So let's say that the UI that I eventually want is something like this. It is recommended to ask for prepayment for this invoice. Details never show again. Something like that. So this would appear in the sales invoice page as I'm filling out an invoice. So I've filled out the name, the items, the discount, the payment terms, the address, and so on. And then I want this notification to appear. So the question is, how can we actually enable this using machine learning? How can machine learning help us do that? So one thing you could, of course, do would be to take this very specific scenario, go through all your data, try in some way to make a big if-then-else function in the code unit that would predict whether customers would pay late or not. But what machine learning promises is that, well, you can basically take all of these problems that are similar, where you have data, and machine learning algorithms will train or give you something that can make those kind of decisions. So in this example, we'll need to get some historical or example data. So these would be actual historical sales invoices. So I've made an example. It's a bit of a Mickey Mouse example, so you probably need more features of the data than this. But in this case, I have 3 examples in my historical data. So for the first invoice, the customer paid $100. There were 3 lines. The postcode that the customer had was urban. The customer, on average, never pays late, always pays on time. And in this instance, the customer was not late. The second one was for $50. There were 4 lines. It was a suburban postal code. Well, I now realize that, maybe the examples are a bit biased here towards urban postcode. But anyway, the suburban guy here, he paid 2 days, or he pays 2 days late on average, and he also paid late in this case, right? So these columns here we call features. So in this case, I have actually 4 features of my historical data that I would like to use as a basis for prediction. The last column here, the last column here is what I want to predict, and we call that a label. So in this example, the label is this late, yes, no, true, false, 0, 1 property. So this is what we want to predict. So in order to train a model, we need both data that has the features and data that has the labels. So what do we next do? Well, we divide the data, the training data, this historical data, into a set that we train a machine learning model on. So it could be that you do it on, you take 80% of all these sales invoice data lines and use that to train a model. You hold out 20%. Then you get a machine learning model that can actually, giving something like this, predict the label. And then you use the 20% to test if you actually get the right label compared to what you had in the historical data. If you're satisfied, if the properties of the predictions are such that you're happy, well, then you're ready to put this model into production. So basically, to enable that notification, we would have to find this set of historical sales invoices, run it through a machine learning model, get a model back, put it into code unit. We'll see how in a bit, such that whenever you do a sales invoice, you give this partial data, these 4 features here, to the model, and it will tell you whether it thinks the customer will pay late or not. And then you do all the stuff that Jesper just showed, hook it into the sales invoice with events and show notification. But let's just go a bit deeper, because I think that's also instructive. So right now I've talked about the process of getting historical data, training data. Then you train a model, and in some way you get something that can predict back. So that's a bit of magic. But let me show a little bit deeper example here. So one example of a machine learning model is a decision tree. So that's basically an if-then-else statement over your data that has been trained by a machine learning algorithm. So in this case, the algorithm that trains the model would try to find the property that divides the data best into categories or clumps that have the same prediction. So maybe the algorithm will see that it's the average late days for customers that best predict whether or not the customer will pay late again. Seems reasonable, right? So the first step in this decision tree could be that, okay, so if the average late days are, I don't know, less than 1, let's predict that the customer doesn't pay late. And if the average late days are greater than 1, let's predict that the customer pays late. Now that's not perfect, right? So maybe there's an accuracy of 80%, something like that. So in 20% of the cases we guess wrong, or the algorithm guesses wrong, right? So even if we predict that the customer will be late, some of them were actually, were not late, some of them were actually late. And the other way around here, right? Even if we predicted that all of these would be late, some of them actually paid on time. So what does an algorithm like that do? Well, it continues to the next level, right? So maybe the next level that the algorithm decides to go into would be to look at the total of the sales line. I had that feature, and maybe another thing to look at would be payment terms, right? So do you get a discount if you pay early? Then maybe people will pay on time or early, and maybe if it's a big invoice, it's more likely that people pay late. So that algorithm, this decision tree algorithm, can continue in that way. The output will be a tree in this case. Now it's a bit better, right? It predicts a bit better. We might want a bit higher accuracy and other properties of the prediction. But what you basically get out of this training, maybe you have millions of sales invoices, or hundreds of thousands of sales invoices that you want to train on, is a model that is compact. So it's basically a representation of this tree. You could even write at least this simple thing here in AL code in a few lines. If average late days are less than, then, and so on. So that's actually a general, often the property of machine learning, that it's difficult or expensive to train them, these models, but once you have them, they're cheap to use. So basically the runtime cost of using this is constant in time. So I have a sales record, I can in constant time get a prediction, whereas the training is more expensive, right? And now that I have this model that I have trained on my historical data, then the expectation is that for future data, that is customers with these sales orders, they would behave similarly to previous customers. And if I have enough data, that would most probably be true, right? So often if you have more data, the better in these cases. Now this is a very simple, even simplistic example. So you would probably make many of those decision trees. You would combine them, you would do all sorts of tricks. But we have tools for that, HTML. But at least I hope you follow sort of the gist of machine learning now. Okay, so let's try to look at what we then have done in NAV 2017. So now I'm going to show examples of time series forecasting. Can you switch, please?
Yep.
So let me just duplicate. So one of the areas in which I said we had used machine learning is in item sales forecasting. So in this example here, or in this demo data there. Here I have a bunch of items. If I go into, let me go into this item, I can see a forecast. So in this case, I'm showing an inventory forecast, and I'll pretty soon run out of these black chairs. So what I could do here is then to create a purchase order or purchase invoice based on this information that I have gotten from machine learning. And whoops, you have a new notification. And in this case, I can then add these items that I apparently have previously bought from First Up Consultants to this purchase order and automate this process. Right. So first of all, this forecast here. Let's look a bit more into how it is set up. So it's a time series prediction, meaning that we summarize over time series data, in this case item ledger entries, and we do that in buckets, in this case of months. So we have a data point per month. We go back we go back 24 periods, so we go back 2 years with this data. When I want a prediction, I want the prediction 12 months ahead. That's maybe a bit over-optimistic on the accuracy of these algorithms. And here I'm saying, this is specific to this feature, that if I look 3 months ahead and I can see that I run out of stock in 3 months, then let me make a stock out warning. Then there's some things here that are maybe particularly interesting. So it's not that we have built machine learning algorithms in AL code. We use this part of Cortana Intelligence called Azure Machine Learning, and these two here is an API URI and an API key that you get by instantiating a prepackaged solution that we've created. And a few more things here of interest. One thing here is that this error percentage, so we're basically saying that if we can see that our prediction is probably more than 35% wrong, let's not show the prediction to the user. So for example, if I have if I predict that next month my inventory will be 10 and the error here is 50%, well, what my inventory will most probably be between 5 and 15, which may not be super useful. But let's look at how you set this up. So in Dynamics 365, this is basically set up out of the box. So we pre-provision. Maybe you saw Konstantin and Camille's talk yesterday. We also provision a bunch of these machine learning web services when we deploy Dynamics 365. We store these URIs and keys in Azure Key Vault and retrieve them. But you can also add them directly. And how do you do that? Well, what you do is to instantiate our model, this time series forecasting model, in the Cortana Intelligence Gallery. So let me try to do that. So this is a forecasting model for Microsoft Dynamics 365 for financials. It's called that for marketing reasons, but it also works just fine for Dynamics NAV. So there's a bunch of descriptions of how to use the model, the properties of the model, even the internals of the model, if you're interested. But there's also a button to actually start deploying the model so that we can use it inside NAV. So let me do that. So it says open in Studio, and now I'm going to open what is called Azure Machine Learning Studio, which is a tool for creating and evaluating machine learning models. So in this case, I'm copying this experiment. I'm going to do it in this region, or options would be these. And I'm going to copy it to what is called a workspace, which is the Azure resource that Azure Machine Learning has as its core, called Smartness TechDays. Let me do that. So now that I have done that, I get a graph. So this is like a data flow graph of this experiment. So I'll go through it in a bit, but let me just show how you deploy it. So you run it in Azure Machine Learning. It validates that the experiment is valid. It takes a while, a couple of seconds in this case. And then you deploy a web service. Let's deploy a classic web service. So that will create an Azure resource, which is a web service that will, when invoked, use this model here. And now this API key that I showed in the UI turns up here. And we are using a request response API for machine learning. So this API URI that was in the UI turns up here. So what I can do now is copy these to NAV and then enable machine learning. But I already did that. So I'll keep it like that. This can also be automated with PowerShell, and we do that, of course, in Dynamics 365. But let me just go back to this experiment and have a look at it. So the core of it is an R script. So R is a statistical programming language that's also very useful for machine learning and for advanced statistics. So this basically gets executed when you execute or call this web service. And what it does is to select a time series model behind the scenes that best matches your data, and then do a prediction on that using that time series model or that machine learning model. And then this part here operationalizes this experiment as a web service. So you give it an input, and the model runs. We split the output into two parts, one of which is actually the prediction, and another one which is data about the prediction. So that's the basics of Azure ML. I'm going to go back to that in a bit. So let's switch again. So but now let's look at some code here. So this is what happens at the core of that inventory forecast example. So in this small snippet, we use the time series API and initialize it with an API URI and an API key. So these were these Azure ML credentials that we got from running the experiment. We then set a filter on item ledger entries, so we're looking at sales. And then we prepare this item ledger data for forecasting. So that's the sort of the core of this API, that you can point to a table, in this case item ledger entry, and some fields on that table. So the first field here is a grouping mechanism. So we might want to make predictions for many items. And if we do that, we can group those by, in this case, item number. The second field here is a time stamp, a date in this case. So since this is time series forecasting, we need a date. The last field here is a quantity. So the two properties that we need to do time series forecasting is a date and a quantity, and we have that in the item ledger entry. I then say that I want to do a monthly forecast or forecast based on a monthly grouping of data. I wanted to start on work date, and I want predictions 12 months ahead. Next thing I do here is to then actually do the forecast. So this is where the call to Azure happens. This stuff up here basically just does data preparation. And finally, I get the forecast and exit the value of the forecast. Switch again. So so in this code unit, I'm basically invoking this method with one item number and then returning the forecast. Okay, so it turned out that for this specific item, we predict that next month we will sell 16.95 shares, or what it was. Right, so but let's look at a bit more detail here. So I'm going to show how the prepared data looks, just for having a deeper look, and how the forecast that we get back looks. So let's run that. So still get this message. So this is the prepared data. So since I only have specified one item or group ID, as we call it, in this example, I have a time series for this item. I also, so actually the 12 that I specified there is how many historical periods I add. So I have 12 historical periods here of sales, going from somewhere in 2015 to sometime in 2016, right? And that is being sent to HTML, and what do I get back? So in this case, I specified that I wanted 3 periods back, so I get 3 periods, right? So 1896S is in period number 13, going to sell around 17, then around 16, and then around 15.6. So what's the other things here? So this is basically the, sorry, shouldn't have done that. So this is the best guess at the value. This is then a delta. So this is saying that, okay, we are guessing, and actually in this case rather somewhat certain, that we are selling 17 items, but we will most probably sell 17 plus minus 3.46. So between at least between 14 and 21 of these. So that may or may not, depending on the item, be a prediction that we can use. And in general, these predictions get better the more historical data you send, and the more stable properties, so to speak, the sales have. Okay, I think that was that. So I hope that showing this time series forecast API convinced you somewhat that this specific form of prediction is rather simple. So it's a matter of filtering your data, preparing it through the time series API, and creating a forecast. So in essence, you don't have to think about any of the intricacies of machine learning that I talked about initially, which is good. So we've done some of that work for you. Let's switch again. So I just want to show one other example where we use this time series API. So in order to do that, I need to be an accountant. So let me become one. Yes. So this is the accountant role center. So in this case, I have a cash flow forecast. So the cash flow forecast is actually a combination of many different things. So money going in, money going out, right? So something you receive, something you pay, some liquid funds, future sales orders, future purchase orders that deduct from your cash, tax, which you have to pay, and also then Cortana intelligence or Cortana intelligence contribution to this total. So this orange line basically shows the total of our cash, and it's going up, which is good. So again, what we do is to do something similar to what I just shown with the items. So we take the history of payables and receivables, create 2 time series, and do a prediction of that. And what we then get back is something similar to this. So these are cash flow forecast entries that come from Cortana intelligence. So it's predicted payables for a period, and it's predicted receivables for a period as well. And we then add those to the cash flow, subtracting the sales orders and purchase orders that we know about already. So basically, this was pretty easy to build using this time series library, because we already had the complete infrastructure and machine learning algorithms in place. Okay, so we also promised to talk a bit about sort of the broader Cortana intelligence. So among others, these other machine learning types: classification, regression, and recommendation. So what I'm going to do now is to do a different example. So I'll explain it, but it shows how you can create a classification model in HTML, and I chose this because it has something to do with financials, or CRM at least, and it also comes with a set of data. So the idea is that, so I'm going to go back to Azure Machine Learning. So the idea is that the scenario is that we're a company, we're doing direct marketing. So sometimes our direct marketing efforts work, sometimes they don't. But we would like to actually predict for a given customer what is a good way of doing direct marketing. So what I have here, except for the time series for our forecasting model, is an experiment that I've adapted or taken from the Cortana gallery actually. So this is more a sort of a problem-specific experiment, but let me explain what it does. So it starts out by importing some data. So in this case, it imports data from Azure Blob Storage. So a blob with CSV data. It then takes some of the columns in that CSV data. It does a split in training data and evaluation data, as you remember I talked about. So in this case, it takes 70% of the data for training. This is the left side of this box, and 30% for evaluation. So if we follow the training path of this data flow diagram, we train a model. Now it turns out that the best way to do this prediction is what is called a 2-class decision jungle. So this is actually something that takes decision trees and makes a lot of it. How did I find that out? Well, I basically did that by trying. Let me find it. So this is decision. By trying different models. So for example, for classification, there's a whole bunch of different models that are all based on decision trees, as you saw. So you can basically try these out and then select the best one. So the model is trained and then scored against that evaluation data set, and then you get an evaluation out. So let's go back to this import data. I just want to show you how it looks, so and why I chose this. So this is the data set. So I think it has some 60,000 records of direct marketing interaction. So it has some recency, so how long time ago did we actually last contact or trade with that customer. It has a historical purchase amount. So in this case, for this person here, it's $142. The person was interested in both men's and women's stuff. The customer is from a suburban place, not a newbie. And the channel that we connected the person on to the person on was phone, in contrast to web or multi-channel or whatever we have down here. It's women's email segment, and well, it didn't go so well. So the customer didn't actually visit the store after that. Didn't spend anything, of course. So just another case. In this case here, with a women's email, also suburban, a little bit less spent and so on, we actually got a visit, but no conversion or no spend. So that is all the data that we are going to train on. The label is this. That's the visit. That's what I want to predict. So so in here, in training the model, I'm saying that here that I'm going to predict the visit, right? And now I can run similarly to what I did before. Run this model, but because this model comes with a specific data set or data set that is specific to a customer and to that data that the customer has, we're going to create a trained experiment or a predictive experiment specifically for that customer and that set of data that I just showed. In our time series example, we actually have a stateless experiment. So we basically send all the data, the historical data, for, let's say, for an item. When we want to predict, we train a model and we predict at the same time. And that can be done because the data is aggregated as much as it is. It wouldn't make sense to send 65,000 rows of data all the time. So this is taking a bit more, the training and so on. But once the training is done and we have a predictive experiment, let's take a minute or two. The predictive experiment can be deployed as a web service similarly to what we've done before. And in this case, again, there's an input, which would then be one record of this direct marketing data, and there would be an output, which is, again, actually a record of this data, but with the label, the visit label filled in. Did we finish? Yeah, so a minute or two on this data set. I can then publish that model, similar to what I did before, this predictive model. I can get an API key and an API URI, and I could even use that inside NAV. So let me show that. So there's this direct marketing prediction. So in this case, there's not such a nice API wrapping all of this. So basically, we use what's underneath the stack of this time series API in this example. So I'm instantiating what is called an HTML connector, again with an API key and an API URI that I got from the experiment. I'm saying that the experiment has an input and an output. Let's call that. And in the data that I sent, the label column is number 11. Then I create an input. So I create an input of a customer contact that I would like to predict. So in this case, let's say it's a bit longer ago that we were in contact with this customer. He or she actually spent a lot, was interested in both men's and women's stuff, rural, and so on. I can then send this data to HTML and get an output here from the data, first line and column number 11. And then I'm just make a message box saying that the customer is predicted to either visit or not visit. So in this case, right, there's no API support for training, and there's some API support for actually using a trained experiment. But let's just run this one and see what it says. So, well, it says that this one is probably not going to visit. Let's take another customer here and see what goes on. So that customer is then going to visit. So I can now use this model in whatever way I want in my application. I probably shouldn't be creating dialog boxes though, but something else. And what you could also see is that the actual prediction is much faster than the training. So it takes a second or so to do a prediction. So this data preparation and call. Let's go back. So almost wrapping up. What else can you do with the Cortana intelligence? So a part we haven't really integrated yet, I would say, is cognitive services. But you could imagine there are lots of things you could do with that. So in this example, I have two of our items taken from the item catalog, and one of the services that cognitive services has is a computer vision API. So I've actually ran these two items through that vision API. So in this case, I get that wasn't. Let me get out of that. Didn't help. So in this case, I get back what Cortana Intelligence think this thing is. You might not be able to read it, but it says, okay, this is probably a black chair, and it's pretty confident. Or maybe not super confident, but with 44% certainty, it thinks it's a black chair. It's very confident that it's furniture, a seat, that it's black, that it's for indoor, on the floor, and it's a chair. And not so confident that it's actually feet, which is good. So the nature of these things is that I think so. The APIs like these continue evolving. For some items, it's pretty good. For others, it's not super good. So this is, as far as I can see, a red lamp, right? But it actually predicts that it's a red bike. To its, at least it doesn't. It's not very confident that it's a red bike. So maybe we shouldn't think that. But at least it can see that it's red, which is not surprising. So APIs like these could be used in a number of different ways. Here's another example where I ran some of the images of contacts that we have through the face detection API. So there's both an API where you can detect who is on the face. You could use that for authentication, for example. But there's also an API where you can detect properties of faces, which you could use for other things. So in this case here, right, there's a guy here with glasses. So the API says he's 42, probably. It's a male. He smiles. He doesn't have a mustache, doesn't have sideburns, very little beard, and he has reading glasses. So this is actually pretty good. A lot of things you could do with that. Maybe coming up. Okay, so ending up or wrapping up. So in summary, we've tried to present a set of features that we hope and expect will make NAV appear smarter, more proactive, and lead to a better user experience, potentially better user experience in NAV. And we've done that by introducing and using this notification API, so it allows developers to build context-aware notification using a builder pattern. So you create a notification, you add the properties to the notification that you want, and you send it off. You can also retract it, change it, and so on. Right now we support these in-context local notifications. We also presented how we used Cortana intelligence. So one part was this time series forecasting API, in which you can basically take one of the 300 or so tables we have in NAV with time and quantity data, massage that, and put it through HTML and get a prediction back. And finally, I showed some of the things that are also possible with Cortana intelligence, but maybe right now with a bit more footwork. That's basically it. Thank you.
Yeah, thanks a lot.
And questions?
Now you get the honor of throwing this one.
Oh, here you go.
I have a couple of questions. You were talking about the prices, and how is the prices gonna be for the on-prem NAV 2017?
Right. So there is, of course, a price to machine learning. It's Microsoft. So so there is actually so there's a free tier, which is absolutely useful for experimenting and also small scale deployments. There's also a usage tier that costs around $10 per month, which you can use for multiple customers, multiple deployments, which contain a large amount of machine learning capacity. Yeah.
Okay.
So
And my other question is, how about doing these experiments? Do you need a lot of training to do it, or can you, as a normal NAV developer, just go in and start doing experiments and trying to figure out new ways to do it?
yeah, so I don't think that any NAV developer should, or all the NAV developers should start doing these experiments. I think that HTML is fairly easy to use and a good way to do data science, machine learning. I think the way to start would be to try to utilize the time series API, which is basically a wrapped up HTML experiment that you don't need to look at, which is prepackaged for NAV.
Okay, and my last question is, how about data, and how do you handle the data? Do Microsoft use the data that they are getting from all the partners and all their customers, or is it just for our own winning?
So technically, in Azure Machine Learning, the storage of data, if there is any, there's a blob storage connected to one of these machine learning workspaces, and if you store data, it goes into that blob storage. But in general, Microsoft doesn't look at customer data, so it goes in there. It's not something that we, as Dynamics or NAV, can look at. So if you trust the sort of privacy features of Azure, you should be good. Okay. Bye.
I have a question about synchronous, asynchronous execution of notifications. Mm-hmm. On the example, you had a call which you have a call which called postcode API. Yeah. What happens if this gets stuck? Because then you call this event, event subscribers take the call and then call something, and then my stuck in this place waiting for the answer from the service. What will happen then? What would be reaction on the system?
Well, as the code was constructed, if the service would time out, then the notification would never be launched. So you would actually never ever see anything. So the user would not recognize that anything has happened. And then the background session would time out, and then that would just disappear. But of course, if you do something on the action that you invoke on the notification, then obviously the system gets stuck. So the asynchronous property is good before you show the notification if there is any delay in whether you need to show it or not. And then the action, you should make sure that it's something that happens immediately. Else you have the same behavior as you have today with just clicking a button, and then you have to stall and stare at your screen until something happens, right?
Yes, but the event itself, it fires synchronously. So as long as you finish the on-validate code, the event is fired, and at that point, the subscriber gets control.
Yeah, but it doesn't block the user, so it...
But you're right. So in some of the cases, for example, where we do item forecast, that can potentially take a long time, right? You have 1,000 items. You want to do a forecast for that, it's probably going to take some minutes. So what we do there is basically to create a job queue entry that runs in the background, stores the predictions, and then we use that whenever we need to present a notification. So that's the solution right now, if possible.
Okay, thank you.
Yeah.
Thank you. First question to the Cortana Intelligence. Have you tried this forecast with a real customer where he maybe buys 1,000 products each day and has millions of item ledger entries to calculate? Is this possible in time?
So we haven't tried it with a customer with millions of item ledger entries, no. Okay. So this is probably for smaller data sets and for a smaller customer. But if you can run this calculation of these million item ledger entries in reasonable time in a background session, then you can use the API. So because the amount of data that you actually send to Cortana is small, so it would be the data preparation that would be the problem, right? And you can optimize that.
Okay, so the time that it takes to send for each item and to get the answer back, what do you expect? What time delay do you expect for each item?
So
less than 1 second, half a second.
So let's say that you have around 100 historical periods. It's on average around tens of milliseconds.
Okay,
so it's pretty fast.